Hello and welcome to my channel. In this video series I am going to cover another interesting Snowflake topics, which is Snowflake functions. Snowflake functions is a very big topic and I will try to cover it in my video part series. So if you have not subscribed yet to my channel, then please do so for the latest video updates. So let's get started. Functions. In Snowflake there are 7 categories of functions. First is scalar function, window function, aggregate function, table functions, system functions, user defined functions, and Snowflake external functions. So in this video series we'll go through each category one by one. So first let's look at the scalar functions. In scalar functions there are 11 different types of functions. Starts with bitwise expression function and it covers context function, conditional functions, date, time, string binary, utility and hash function, semi-structured data function, and etc. So let's look at our first function, which is bitwise expression functions. In bitwise expression functions there are BITAND, BITOR, BITXOR, BITNOT, BITSHIFTLEFT, BITSHIFTRIGHT, and GETBIT. So we'll look at it in a practical manner. So let's go to demo for the bitwise expression functions. Once you log into your Snowflake account, let's create our sample database. Let's create one sample table in it. Create table. I name it bit_expression function. Let's create 2 columns. First is bit_1. We'll name it as integer. Then let's create another bit_2 integer data type. Let's create this table. So if you are wondering how I'm running this command, there is a shortcut. Just move the cursor to any statement over the statement and press Ctrl Enter, and that will run the command. So our table is already exist. Next, let's insert some sample record in it. So insert into our table name function, pass column name, comma, bit_2 values. Let's insert, let's say first try with null. Let's insert 2 null values. Then same digit, let's say let's change it to 3, 6, and let's also do 6, 3. So you can insert any record. I'm just inserting this sample data. So let's run it. Now that we have inserted 4 records, let's verify it from function name. As we can see, we have inserted 4 records, 2 columns, bit1, bit2. Now let's try our bitwise functions. So first is x. Okay, so first is bit and then bit or, and let's say bit XOR. Next, let's test this bit and, bit or, and bit XOR operations. So let's write one select query. Select. Let's first select our 2 columns, bit1 and bit2. Then use bit and operation, and we'll pass our first column which is expression 1, and we'll pass our second column, it's expression 2. And similarly for OR and XOR, we'll repeat the same. Instead of we'll write OR, here we'll write XOR, and we'll read the records from our table. So let's run this query and see the output. So here is the output for our BITAND, BITOR and BITXOR operation. So what is happening here is, in Snowflake, this BITAND operation will first convert the digit into binary, and then it will apply that AND operation on it. So in normal SQL, we know, like, first we need to cast the digit value, maybe 3, as bit, which is like I'm converting that digit into binary, and then we apply that bitwise operator on it. Here in Snowflake, we can directly use this bit AND function or AND bit XOR function for this. Next, let's test our BITNOT function. So we have BITNOT. Let's write one select statement. Select our column and then use BITNOT, and let's pass this column inside that BITNOT. Let's select records from our table. So as we can see, it has returned BITNOT result. So for 2, BITNOT is -3, for 3 -4, and for 6 -7. So if you are wondering why this -3 is coming for this 2, so first what is happening here, this 2 will be converted into binary and then the NOT operation will be applied on it. So for example, so this is called the seconds complement. So if we go to Google and look for 2's complement, we can see for value 2 we have 101. So let's copy here. For value 2 we have 101, and for -3 we have 101. Sorry, for 2 we have 010, and for -3 we have 101. So as you can see, when we apply NOT operation, this 0 becomes 1, this 1 becomes 0, and this 0 becomes 1. Let's see for 3 as well. So if we have 3 as an input, for 3 we have 011, and it is returning -4. So let's look for -4, it's 100. As we can see, when we apply NOT operation, it is just returning 0 1 0 0 1, like it is converting this 1 into 0, 1 into 0, and 0 into 1. So this is about the BITNOT operation. Next, we'll look at the GETBIT, then BITSHIFTLEFT. Let's say GETBIT, then we have BITSHIFTLEFT, and lastly we have BITSHIFTRIGHT function, bitwise operator. So let's write our select query for this. First we'll read our first column, then we'll use this GETBIT function and we'll pass our first column in it. So this GETBIT function will return the bit position, so whatever the position we will pass. So first, this is a value and this will be the position, bit position. So syntax for this is GETBIT. First we have that value, then we have that position. So first this value will be converted in binary, and it will return the position of either the 0 or 1. So we'll look at the example further. Next, we'll write our next function, which is BITSHIFTRIGHT. So here the syntax is, first we need to pass our column name, and then we need to write the shift that we need to do, which is 1, and then next we'll write our first column and then shift that we need to do. We'll select the records from our table, which is bit expression function, and if I run this, I will get the result. So let's understand what is happening here. Let's write one function actually, which will convert this value into binary for us. So here in Snowflake, we can write function like create, or we call it as a UDF, create or replace function. I name it num_2 binary, and then we'll accept value as a parameter. Let's returns string, and language as JavaScript. We'll write as $, and then if hold it as value, we'll write if loop, and we'll check if the value is not null. So if it's null, then we'll simply return the value as it is. Let's say return as it is. Else we'll go to the loop, and what we will do here, we will use JavaScript unsigned right shift operator for this to convert the digit into binary. So here we first declare our variable var bin equal to, then we'll pass the value, we'll apply that right shift, which is unsigned right shift, 0, the base 2, and finally we'll return that value. Let's complete our let's complete our function. So if I run this function, now we have created our function. Let's use this function in our select query, and we'll pass our first column name as input. So if I just run this query, I can see it has converted it into binary. So for 2 it is 1 0, for 3 it's 1 1, and for 6 it's 1 1 0. So basically we read it from the right. So it's 0 1, it's 1 1, and it's 0 1 1. So here at GETBIT we can see we are returning the second bit. So here we can see we have 0 at the 0th position, we have 1 at the 1th position, but there is nothing, that means it's a 0 at the second position, so it will return 0. So what is happening here is, in GETBIT, here 1 1, this is a position, and this is a binary number, and position starts from right. So this is 0th position, and this is first position. So for this one, this is 0th position, and for this one, this is first position. So if we have, let's say, 6 as a binary number, then it will add 2 here. So this 0 is at 0th position, this 1 is at 1th position, and this 1 is at the 2nd position, and that's what the GETBIT is returning. it's 1. So this get bit is returning this 1 from here. So let's say if we just change this get bit to, let's say, return the first position of the bit, and if we just run this query, we can see at a first position we always have 1. So here 0 and 1 we have 1, here 0 1 we have 1, 0 1 2 we have 1 at the 1th position. So here in what is happening at the bit shift left, what it will do, it will just add the 0 to the last. So what is happening, so for 2, let's say for 2 the binary number is 1 0, and this is for 2, and let's say for it is converting into 4. So what will happen, so for 4 what it will do, it will add the 0, then similarly for 3 it will make it as a 6. What it will do, for 6, for 3 we have 1 1, and 6, what it will do, it will make it 1 1 0. As we can see here we have a 6, and next for 6 we have 1 1 0, and what it will do for 12, it will make 1 1 0 0. And that is what happening in the bit shift left. It is adding 0 to the last. It is adding 0 to the first because we read it from the right. So this is like 0 1 2 and 3. And for bit shift right, what we will do, we will remove the first bit. So here what will happen, so we know for 2 we have 1 0, for 1 1 we have 1, for 3 we have 1 1, for 6 we have 1 1 0. So let's remove first bit and we get output like 1 1 and 1 1. So this is 1. So in binary, when we convert it into decimal, 1 is 1, 1 binary is 1 decimal, and 1 1 binary is 3 in decimal. So in the next tutorial I am going to cover second expression function, which is conditional expression function.